In this session, we are going to discuss about the design thinking for supercapacity. Okay, we have a lot of conventional energy storage devices like battery, supercapacitor. So, what will be the new technology for the supercapacity? So that's why we are going to open for the design thinking for this supercapacity. Let's discuss.
So, in the design thinking, there are 5 stages, which is empathy, define, ideate, prototype, testing. So, now I am going to give the empathy part. So, there is a lot difference between the supercapacitor, and the battery. The supercapacitor is the fast charging and fast discharging device, and the battery is slow charging and slow discharging. And the supercapacity is the hybrid device which is reduces the bridging gap between the battery and supercapacitor, which is fast charging and slow discharging. So
we are trying to achieve these approaches. So fast charging and slow discharging. Okay, the gap between the battery and supercapacitor. Okay.
Next stage is talk about define. It's about clearly state the problem statement. Current energy storage system that cannot combine both fast charging and long backup life safely. Goal: create a supercapacity that not combines the both at one time.
Okay.
In Ideate, combined battery high energy and supercapacitor high flow. Use supercapacitor for quick burst and battery for long usage.
Yeah, the constructions and the laboratory scale fabrications involved manganese dioxide as cathode and activated carbon with quantum dots as anode.
So there are two types of chemistries in supercapacitor and supercapacity. So the symmetric, asymmetric. Okay. So symmetric means we are taken the cathode and anode are same material, but we are approach for the asymmetric. So the one is the anode, another one is a different material. That's why we taken for the M1O2. So that's the one kind of material. So it is a purely asymmetric type.
And we have water-based electrolyte in between.
Why you are choosing an aqueous-based electrolyte? So what are the reason?
So it has the high conductivity properties, and as well as we should further improve that shielding and screening shielding effect so that it just.
But the existing technology we are used for the there's an non-aqueous electrolyte. So what are the differences here you are choosing for the
So
aqueous?
in non-aqueous, I mean like in solid electrolytes, they have no thermal runaway. There are no chances of thermal runaway, whereas in liquid.
So many safety issues.
Yeah, there
Okay.
are safety issues that we must actually have some knowledge about it. So the result stated that it have a hybrid output gave us 1.5 volt. Approximately.
Yes, that also we are going to optimize.
So
No?
that,
So
so that this hybrid system have ultra fast charging and as well as high efficiency.
Okay. So how to fabricate? You are to tell about that is a M1O2. So another part is.
Another part is that.
So M1O2 act as a cathode
Yes.
material. So what about the anode material?
Anode, as I discussed before, activated carbon with quantum dots.
Okay. So quantum dots, what way it helps to improve the performance of the supercapacity?
Maybe the mobility of that quantum dots may further, the mobility of the quantum dots may help in the performance and efficiency of the further laboratory scale fabricated.
So mainly we are focusing here the fast charging. That's why these are the better ingredients to improve the performance. So this is there is a quantum dots and CNT, graphene. So that kind of materials also we are trying to improve the performance. So but mainly we use it for the M1O2. So another is activated carbon. Okay, we don't remove completely the activated carbon. So activated carbon is a very important part of this supercapacitor as well as a supercapacity. So what are the applications? why we go for supercapacity? Already we discussed a lot of points. So what are the main objective and applications of this supercapacity?
Supercapactery
So what way we replace the other? There is a conventional energy storage devices.
yes, sir, we can use with smart grid energy storage devices, and as well as it won't have that much, it won't gather, occupy much space compared to batteries as well. So, and further we can given an acknowledgement or some promise that it can even perform better than the batteries, further present batteries, and moreover further improving the future upgrades, and we can even more build a lot of things, and we can use it for various wider applications with the supercapacitors.
So what are the differences between the solid state and the normal aqueous based or non-aqueous based electrolyte? Generally, I am asking about the solid state energy storage devices. So another class is with electrolyte.
The electrolyte, liquid electrolyte.
Yes.
So aqueous electrolyte it present in the liquid form. So the solid will be at the in between, in the solid form. The electrolyte will be in between the cathode and anode, which are being further in between the current collectors, so that there won't be leakage further. And we can expect is that there is no thermal runaway. So there won't be any fire accidents, and we can expect that to perform in extreme conditions like high temperature or any other further physical conditions like pressure involved. So there won't be much factors affecting the solid electrolyte.
So what is your plan to use it for this technology supercapacity? Whether you are using for the liquid or solid state?
Yeah, we can now build a prototype on solid electrolyte, but it won't it won't perform as compared to the liquid electrolyte in the present stage. So that we can further try some various combinations of solid electrolyte, and further we synthesize it, and we can do laboratory step fabrication and testing, and further we can do a better results and compare it with the liquid electrolyte for further upgrade.
Any other applications?
So,
So especially for our ultimate aim is already existing conventional energy storage devices, and with the supercapacity, it improves the better charging. Okay, that is our ultimate aim. So we cannot replace the entire conventional battery system. Okay, so we 50% of the battery and 50% of the supercapacity, it improves the better charging and better performance. Okay. Any other points? Okay, thank you.